Hello students. So now we will solve one another numerical for cooling and dehumidification. So for that let us read data. So here flow rate given 39.6 meter cube per minute. Entry at the entry temperature is 31 degree centigrade dry bulb and 18.5 wet bulb, and ADP 4.4 degree centigrade, and cooling effect is all given 12.5 kilowatt. So let us first of all understand the data. So here you can see this is our condition. So here this is duct, this is inlet condition, TD1 is 31 and WBT wet bulb temperature 18.5, coil temperature 4.4 degree centigrade. TD2 we need to find out, but cooling effect is given. Cooling effect is 12.5 kilowatt, and this is basically m dot h1 minus h2. So let us write down that. So before that we need to mark this point on psychrometric chart. So let us do that. Let us highlight those points on psychrometric chart. So first of all, what is dry bulb temperature? 31 at the inlet, 31 dry bulb temperature. And what is wet bulb temperature? 18.5 wet bulb temperature. So on the basis of these two, so from here you will have to extend this 31, and where is wet bulb temperature? 18.5. So from here you will have to extend it. So both will meet at, I think, this point. So this is our point 1. So this is point 1. This is how you will have to find out point 1. Now coil temperature is also given 4.4 degree centigrade. So let us mark that coil temperature here. So that is basically 4.4. So this is our coil temperature. So now you will have to connect both of these. So this is your ADP and this is your point 1. Now we will have to find out point 2, but before that we require H1. We require H1. So what is H1? Around 54. H1 is around 54. So let us write down that here. So 12.5 is equal to mass flow rate. Now mass flow rate is given 39.6. Okay. Now to convert it in kg per second, here we will have to multiply it with 60, and here you will have to multiply it with specific volume at point 1. So what is specific volume? Now here you can see what is specific volume here, 0.88. What is specific volume here? 0.86. So what will be the specific volume here? Obviously 0.87. So specific volume at point 1 is 0.87. Clear? So that we will have to write down here 0.87. So I already told you that why we have to do this procedure. So what was the H1 we got? H1 54. So H1 is 54 minus H2. Now we need to find out H2. Clear? Now why we did this? Now here we can see it is given in meter cube per minute. So we are dividing it with 60. So what will be the unit here after dividing 60? It is in meter cube per second. It is in meter cube per second. Now if we will divide this with specific volume, so what is specific volume unit? Meter cube per kg. So whenever it will go upper side, it will become kg per meter cube. So here what will happen? You can see meter cube get cancelled. So that's why your answer will become kg per second. So that's why we will have to do this procedure. That's why we will have to divide it with 60 and multiply it with specific volume. Here you can see, here we will have to do like this. We will have to divide it with 60, and here you will have to write down specific volume, because we require answer in kg per second. That's why. So now let us find out H2 from here, but for that we require a calculator. So initially let us find out 60 into 0.87. 52.2. 52.2. So here 39.6 divided by 52.2. Now this will be here 54 point minus H2. Okay, 39.6 divided by 52.2. 39.6 divided by 52.2 is equal to 0.75 or 0.76. 0.76. Here we have 54 minus H2, so here we have 12.5. So we can write that 54 minus H2 is equal to 12.5 divided by 0.76. 12.5 divided by 0.76. Okay, so what will be the answer here? 16.44. So here this is our 16.44. So what will be the H2? H2, 54 minus 16.44. 54 minus 16.44. So your answer will be 37.56. So H2 will be 37.56. So this is answer 37.56. So let us draw that 37.56. So where is 37.56? So 37.5. So here 36, 37. So from here you will have to extend that. So this is your point number 2. This is point number 1, point number 2 and ADP. Clear? So now what is asked? So that we will find out. Determine dry bulb temperature and wet bulb temperature of the air leaving the coil and bypass factor. So let us find out dry bulb temperature at point number 2. So what is dry bulb temperature at point 2? So here you can see that this is 20. So dry bulb temperature at point 2 will be 20 degrees centigrade. What is wet bulb? How can we find wet bulb? So here you can see this is wet bulb. 10, 11, 12, around 13. So wet bulb will be around 13 degrees centigrade is your wet bulb temperature. And now we will have to find out bypass factor. So for that you will have to remember this is 20. So now let us find out bypass factor. So bypass factor is equal to what is that? TD2 minus ADP divided by TD1 minus ADP. So here what is TD2? TD2 recently we found out TD2 is equal to 20 degrees centigrade. Here you can see this is 20 degrees centigrade. So 20 minus ADP is 4.4 and TD1, what was the TD1? I think 31 degrees centigrade. TD1 was 31. Okay. So here let us write down 31 here and let us write down 4.4 here. So this is how we can find out bypass factor. So 20 minus 4.4. 20 minus 4.4. So that is basically 15.6. So here 15.6 divided by 31 minus 4.4. 31 minus 4.4. So that will be 26.6. So here we have 26.6. So 15.6 divided by 26.6. So 15.6 divided by 26.6. So what is answer here? Answer is 0.58. So your bypass factor is 0.58. So let us check all these answers. So three answer we have. First is this dry bulb, weight bulb and bypass factor. So dry bulb 2013. So let us check that. Okay. So here you can see this is our 20. So 18.5. And what was the weight bulb? 12.5. And in our case 13. Okay. So both are basically nearby, dry bulb and weight bulb. And finally it found out bypass factor. So 0.5146. So what is bypass factor? 0.58. Okay. So this is how we can find out bypass factor. So thank you all for listening me. Next time we will solve another numerical.